So in this video, we're going to create a heat source. In this example, it would be a Peltier tile, a heat sink that will be a standard aluminium fin type, and then we'll create a cooling source. So that will be a fan. Now we'll draw it so that it's presentable, and then what we'll do is we'll put them through the simulation, and we'll have a look at how the orientation of the fan to the heat sink affect the cooling rate. If we just start with a sketch, and we'll draw a rectangle on that sketch that is 45 by 60. We're going to map out where the center is. So we'll just go straight to the center rectangle. Just have a look here till we see that triangle. We'll just go here till we see that triangle. Then we'll come out, and where those two green lines intersect is the center. We'll come out. We'll just type in 45 because it's the same height, and then here we will also type 45. And then what that's doing is it's giving us just a guideline as to where the first fin would be, and then it goes all the way across like that. Now this here would be flat and would need the holes to secure. Now this time we are going to use the line, and we're going to use construction, and we're just going to go here, and we're just going to go there. And what we'll do now is that center of that line and that center where you see the triangle of that line will actually be the center of from there to there, and of course from there to there. So let's turn off our construction lines and we'll zoom in a bit. Click that, and that is a 4mm diameter hole. And we'll press C for circle again. That's a shortcut key, and we'll just type in 4 there. Now it's time to do the fins themselves. So a bit of a clumsy way, but it works. I just go from that point there. Now we know it's 45, so I'm going to press tab, and the fins are about just less than a millimeter, so 0.8. And they come in about that. Okay, and of course I think there's 9 of them that stretch all the way across. So we'll go to create a rectangular pattern. The objects or the lines we're choosing is that one and that one. We're going to go that direction, and we're going to 45 minus 0.8, and that should bring us straight into there. And of course there are 9 fins. Okay, so now we have our base, we have the holes, and we have the fins. Okay, so the fan we're going to draw is a 12-volt 0.12 amps. It's quite a small fan, about 39 millimeters square. So if we just click there and we just type in 39 there, 39, and just enter that. Okay, so now it's time to do the opening. So just do the circle tool again. Just run the cursor across. There's the triangle. Run the cursor across. There's the triangle, and that should connect. And the reason I do that is because sometimes it doesn't highlight. I'll click there, and that's about 37, so it's quite thin on the sides. And then there should be another circle in the middle, which is about 22 diameter. And what's happening is these would be the blades. Okay, so we can actually do the blades. So to do that, I would just draw a 3-point arc. Just zoom in a bit. We go here and there and come out. I then offset that from there to there. It's a bit thick, but because it's not actually working, that seems to be okay. I'm going to press the letter T. That's the scissors over here, so shortcut key again, and just trim that and that. Okay, so now everything should be joined. Now we do want the 4 holes here just to make it look a bit more accurate. So circle, construction, go straight in. And if we do 44 for the diameter there, and press enter, and then what we're doing is we're just trying to find that hole here. So we'll go line, we're keeping it in construction, and from there it's going to go to the center, and then press that tick. Okay, so that's the hole there. And I believe these are 4mm, so we'll do a circle, click off construction, find that intersection, and type in 4, And we can actually create that 3 more of those. So we just go create circular pattern. The object we want to create the pattern on is that one. The center point is that one, and we're just going to go to 4, and you can see that that will then rotate it 90 degrees exactly, and we're okay with that. Okay, and then of course again a bit accuracy here, we can fillet these edges, so we just go to fillet tool there, click that one and that one. I think I said that was 4 before, so do 4 there and 4 there. Now I can right click and just repeat the fillet, 4, and right click 4 there and there. Okay, so that's our basic shape. So we can finish the sketch now, and the first thing to do would be to rearrange that. I'm going to extrude this whole thing, so just going to click and just sweep that across. And the reason I can do that is because I've got that, my paint, as a selected. Most people default is the window selection, which is fine. You can just change it, or you can do it individually. Now I'm going to here click a minus 4 mil, and that makes the bed of the aluminium heatsink. And the reason I went minus is because when I turn my sketches back on, my sketches are now on this side, as opposed to if I hadn't done, then everything would be upside down. Now, ironically, we're actually going to flip everything anyway. Okay, the next part is these fins go up to 22, and then the center ones are reduced by half the thickness of that. It's not too important, but if we want it to be as accurate as possible, then we should really observe that. Okay, so the next part is to extrude the fins at 25 millimeters. So 1, 2, 3, 4. Now it's multiple selection. I don't need to press shift, and that would be 25. Now we know that the fins actually get a little bit tighter, so there's no reason why you can't do that. We can just click this, but I wouldn't do it too much. We're looking at a minus. You can do a 0.5, actually it looks a bit better. And everything's joining. If I turn the sketches off, things become a little bit clearer. So we will just go to modify, chamfer, click that edge, and just put 1.5 in. Okay, so the last thing we need to do really for this heatsink is to just cut away 4.5 millimeters down, so that when we create the fan, it will sit nicely in place. To do this, create the sketch. We're going to select the side of the heatsink this time. Click a rectangle. We're going to go in between these first two, slightly above, and we'll come all the way across there. Then we'll press tab, and we're going to type in 4.5, and then press enter, and we'll finish that sketch, extrude, and push that all the way back. Okay, so that should be what a standard heatsink looks like, an aluminium one. Now, I have been saying it's aluminium, so why don't we make it aluminium? We're going to adjust the physical properties of this. We'll just call it the sink. Right click, physical material. Now, normally this would be a aluminium 6061, and then we'll drag that over. So now that is 6061. Close that. Next part is this fan here. So we're going to extrude the outside, and we'll extrude that to 9 mil. And then we'll extrude the inside, and it's slightly smaller. We'll just say that's 8 mil. Next thing we need to do is we need to draw the top of the fan part. So we go to create sketch, and we're going to select the slightly shorter center of the fan. Let's do the circle. We'll click from there, do 35.5, and then we'll do an arc. It's slightly away from that, so we'll go here, there to there, and then again we will offset that and OK. Now we'll press T and just trim that top part off there. Now it's just occurred to me that I should have really had this circle at the bottom as well. So I'm going to hide body 3 and body 2, the first sketch that we did. Just going to edit that sketch, and I really want that circle from here all the way up to there, 35.5, and that just closes that off. And of course I can press T and trim that and that. Let's finish that sketch. So now we've got this here and that there. Let's turn these bodies back on. Okay, we're going to loft. So create, loft. First one we're going to select is that. Then we're going to just hold our finger down and we're going to select that profile. And instead of join or cut, we're actually going to go new body for this one. Then just press OK. Okay, so that's our body there. So what we're going to do is going to create quite a few here. So we've already got body 4 selected. We're going to create. We'll go to pattern, circular pattern. We've already selected it because I already did. If you hadn't have done it, then it would ask you to select it. Select that. The axes, if you can select the center point. Otherwise, just select the face. And I think we'll go 10. Okay, and press OK when you're happy with that. Now again, we can chamfer these if we need to. So we're just going to modify, chamfer that one, that one, that one, and that one, and we'll just do a 0.5. And then we just need to draw a bar that goes all the way across, because obviously there's nothing holding that. So here again, right click or second click, create sketch, and we will go to rectangle once more, center rectangle, find the center, and just draw a line through there. So let's give that 1.5 and finish that sketch. So if we go to extrude, we come out 1 mil, make sure that we're joining, and if you want, you can even fill it that side, that side, that side, and that side to make it look a bit more realistic. Okay, now we've got lots and lots of bodies, and the reason is these are all new bodies. So we're just going to join them. So we'll just hide the sink, and we are going to join everything together here. So we'll go to combine, the target body, let's call it, we'll just select body 2. And then the tools are that one, that one, that one. We're just selecting everything. We'll just join it. Make sure you don't keep the tools in this case. Okay, so now we've just got 2 bodies. We've got the fan, and we've got the heatsink itself. Now the next thing is we need to quickly do the Peltier tile as well. So for that, very simple, we will just create a sketch, and we're just going to do a 45 by 45 square. So 45, 45 square, and then finish that sketch and extrude it to about 4 mil. Okay, that will be our Peltier tile. I'm going to just turn the sketches off, make it a little bit easier to see. So we've got our components. Click that, press M, and we're just going to type in 180, and that just makes it easier for me to see the heat source later. Rename that, click it, press M, and we will just drag that into place. Look on the side, let's drag that down so it's touching. 2 ways of doing the fan. The first one is to put the fan in here. We will now copy them all. So highlight, shift, highlight, press M, but don't move it. This time create a copy. I'm going to go to a 3D view. I'm just going to slide that out of the way like that. Press M, and we'll put that into place. So straight 180. And we'll move that down spin it around. So this is our first way. So the air is drawn in and then comes out there. The heat dissipation would depend also on the design of the body. So that one would be about there. And we can either put that right against it or you can leave it, but let's put it right against it and have a look. Okay, so we've got two different versions. So let's save that. And now we're going to go from design to simulation. We'll select electronics cooling. We'll create a study. Okay, we can't do these both at the same time. We have to do one and the other, and it does take a bit of time. But it's not. You can turn your computer off. It's being done on their servers. So the first thing to sort out really is the heat source. So if we go the heat load, internal heat, and the Peltier tile standard range would be 60 watts. Now the heatsink, so we'll just, if you click here, you can heat transfer. So we'll select the heatsink, and that is that one. The cooling, so again, forced flow, and the cooling there. And the first thing we need to do is just make sure that arrow is pointing down, so the flow of air is coming out. Standard magnitude for this, we'll just change the units, is a CFM, and we're looking at about 70. To get this going, what you would do is you go solve and then solve. Now you can't do locally because it's in preview, so you'd need to do on the cloud. You'd select that and then solve that study. When it's ready, I'll show you exactly what it looks like. For this one, we're going to actually do a new study. And there, and it's exactly the same detail. So we'll just put the Peltier, so that's the thing that's giving heat, 60 watts. The heat sink, just highlight the heat sink there. And the cooling, and that was 70 CFM, so go here. And okay that. And then exactly the same. So just making sure that our flow is correct. I don't really want it to draw through. I want it to pass through. Again, you can do both and find out. So if we just go back to this one here, so the fan, and I'm just going to flip that direction, okay? So now the air is coming out and going through. And again, it does matter because your fan does have a direction. So whatever you decide, make sure your fan is facing that correct direction. So now the air is being drawn and comes through. And because they're separate studies, the heat from here won't affect this one. And again, exactly the same way, go to solve, solve, and now you can actually do all two. So if I was to do it, I would make sure I've set up both simulations and then go and solve two studies. Okay, what does it look like? So study one, right click, activate study, go to results, simulation results. You will see it like that. One way you can do is click the temperature scale, and you'll be able to see where the heat's coming from and how it's being dissipated. I like this one best, this sectional view. And what you can do here, you can just drag that across. Okay, so we'll just do it right in the middle of that heatsink, and you can see this is what's happening in the center of that heatsink. Now the other thing you can do is just hover your mouse over. So we're looking at the Peltier tile on the hot side would be about 34.7, let's say 34.8. And by the mid-range, now you can, of course, you'd screenshot these and remember your values. And this time we're going to go study 2, activate that study, simulate those results. Now this is in the way, which is why I hid them, but just ignore them for a minute. We can go here, again, very, very similar to the last one. But when we go here, you can see that the temperature is higher. I guess what this means is this is not as effective as that way, but again, it completely depends on the design of the casing that you're putting everything in. And if you don't have any air vents, for example, then it doesn't really matter. So I hope that's helped figure out how to use this simulation. And that is it.